Ja, hallo zusammen. Dann gehen wir zu den Formalia. Jetzt haben wir 1, 2, 3, 4, 5, 6, 7, 8, 9. Das passt dann ja. Dann sind wir genau 9. Ähm, Dann brauchen wir auch nicht irgendwie gucken, weil dann haben wir ja alle. Weil die ersten 3 Themen wollte ich ja unbedingt, dass die verteilt werden. Ähm, aber wir haben ja eh alle Themen. Gut, dann würde ich das Ganze so machen. Ich habe von Ihrer einen Kommilitonin eine grundsätzliche Präferenz für das erste Thema bekommen und frage dann einfach in die Runde. Will das noch jemand machen? Ansonsten, das würden Sie auch gerne machen. Ups. No, no. So, dann bräuchte ich Ihren Namen mal kurz. Bitte? Genau, ich nehme jetzt erstmal nur die Nachnamen und den Rest machen wir nicht. Selim Hanov, so glaube ich, ne? Da muss ein N hin. Und Selim. So, und Sie wären? Ismail. Okay, dann machen wir das so. Wie mache ich das jetzt am besten? Mal 10 wären dann. Sie nennen mir jeweils eine Zahl zwischen 1 und 10 und dann losen wir. Tja, Sie kriegen auf jeden Fall ein Thema. Ich gehe jetzt einfach von 1 runter und wenn es mehrere gibt, dann losen wir jetzt einfach und natürlich. Oder wenn Sie jetzt zurückziehen und sagen, dann haben wir weniger zu tun, ist das auch okay. Ansonsten losen wir einfach. Okay, gut. Dann schiebe ich schon dahin. Wo wären Sie dann zu verorten? 1, 2, 3, 4, 5, 6, 7, 8, 9? 3, dann packe ich Sie doch schon hier hin. So, Frau Creto, können Sie uns eine Zahl zwischen 1 und 10 nennen oder eine kurz eintippen? Sie denken sich auch schon eine aus. Die 3 und was wollen Sie? 6. Okay, so. Dann machen wir ist gleich 10 mal Zufallszahl, Klammer zu. Und wer näher dran ist, kriegt das Thema. Zack. 7, dann sind Sie, Frau Selim-Hanow, haben das Ganze. So, Frau Creto, Sie überlegen sich, wo Sie noch hin möchten. Sie wollen auch Statistik mitmachen? So uh, you have only you're an IBS student or what? Okay, because we said since we have only Germans here that we give this lecture in German. Pardon? Okay, so okay, then it's the case that we switch to English. It was a quite nice. This is a déjà vu for me because I studied 1 year in Uppsala in Sweden, and there was also said, well, maybe you know the Scandinavian guys, they all are able to speak English, and then it was promised to us that if we participate in some courses, then that these courses would be in English. And then I went to Uppsala, and I think it was thermodynamics or what, some, yes, it was thermodynamics. And it was a lecture which everybody who studied physics had to participate. So it was about 60 guys within the lecture hall. And then the professor came in. I was sitting in the first row, and he asked then, well, I was asked to give this course in English because we have exchange students. And then he asked, well, how many? Then I raised my hand. I rose my hand and looked back, and I was the only one. And then the professor said, well, so we do it in English. Give him a warm welcome. And they were really happy that this lecture was not in Swedish, but in English. But anyway, it's okay. We do it in English. But then I have to invent another tense topic. Oops. This will be then a surprise topic. I don't know yet. So we will do another one. Heteroskedasticity. This was Miss Cretu. So another one with heteroskedasticity. No, then you have one. Oops. Here. Right. Funny format. Okay. No. So another one besides Miss Ismail with autocorrelation. No. So you have it. So then I have some students who are doing parallelly another course, and there they have an external talk, so they are excused for today. And there was one fellow colleague who was interested in the fourth topic, ARMA processes. And unit root test. Another one? Then we have it. The fifth choice of very, yep. And misspecification. Who is interested in this one? Yep. And your name? Wendland. Have I written it right? Okay. Another one? No. Okay, great. Then very interesting and very important. Maximum likelihood. So, Struss was the name, yeah? Like that or with another S? Okay. So, another one interested? No? Then we have KFM. Yep. Finance topic. So, another one? You also? Yep. Then your name? Your name? So, Julia, your choice. Number between 1 and 10. And your number 3 und 8. So, ist gleich 10 mal Zufalls. Ups. Und Action. Julia. So, 8, 9, 10. Another idea? Generalized method of moments, limited dependent variable models, and number 10, surprise topic. Number 8, okay. This would be generalized method of moments. And this would be your choice too. The next one. So another one, number 8. Nope. And then let's be the 9th one. And there I have another fellow student who was also interested in this topic. Eileen, ich glaube, du kennst den Tammo, dann würdest du jetzt für ihn eine Nummer ziehen. And your name? Pardon? Pardon? Can you spell it? Yep. I-O. Okay. So this is your last name or your first name? Yeah, and the last one? Okay. So, Eileen, du übernimmst mal für den Tammo and I need a number between 1 and 10 from you. 6 und 4? Okay. So, then again, 10 times Zufallszahl Enter 8. So, Mr. Frias und Tammo kriegt dann das Überraschungsthema. Then we are done. So everybody has enrolled in the Moodle course because then I will just copy your email addresses and so on. So, okay, now we are 10, but anyway, then we have the second part of the exam, so to speak, here, because I want also from you not only focusing on one special topic, but yeah, doing some standard, so to speak, doing also some standard statistics. And there we have 4, so we will build 2 groups with 2 guys and 2 groups with 3 guys. So it would be nice. We will do this because Julia and Tammo will enter at the next block. So you can start to interact, that you are going to form these 4 groups to, pardon? This? No, this is not in Moodle. Yeah, for sure, for sure. And, but that you are, yeah, just start that you are forming 2 groups with 2 guys and 2 groups with 3 guys. And yeah, the topics, yeah, this is quite standard. So nothing really harmful, so to speak. So the first one is we have started last time just to download a data set and doing some descriptive statistics, calculating means, measures of volatility, and so on. And here you should then choose another data set and more or less redo it. And I gave you also a sheet of exercise, and there that you prepare. I have to look at it if you should then do the full one or 4 or 5 of these exercises, and then yeah, maybe with a special focus on this, let me say it, new moments I introduced, so the third and the fourth moment, the skewness and the kurtosis. There it would be nice if you just start to read a little bit and yeah, talking then a little bit why are these measures needful and where are you using them, and so not very much, but um, uh, to do this, and then the first exercise sheet, and I will have a look and this how many of these exercises you should then also prepare and present this then in 2 weeks to your fellow students. The next one is that I will introduce, so to speak, inequality measures. There we have similar to a mean and volatility measures and so on. Think about, for example, the income distribution in a country. And then maybe you know that on average, um, measured in GDP per head, the United States are richer than we. So they're measured in US dollars, then GDP per head is quite a lot higher than the GDP per head in Germany. And then, of course, yeah, one starts to think about, is this society then, so to speak, overall richer than we in Europe? And then you start about who owns the capital, who owns the money in the United States. And then maybe you know that you have within the United States, relatively compared to the whole society, to all people, a much larger number of very rich people. And for this, then we formulate that the income distribution in the United States, because we have there many very rich people, the richest people in the world. Elon Musk, the last estimate was 800 billion US dollars. Maybe he will be the first trillionaire in the world. And maybe you also know that unfortunately in the United States we have much more or much more very poor people compared to Germany or in general to countries of the European Union. And for this, in descriptive statistics, we also developed some numbers you can calculate and then to look a little bit deeper in such a distribution. We had something like this already when we talked about the median and the arithmetic mean, that they quite often do not coincide, and that then you also can say, well, maybe you have here on the right side in the income distribution a tail, which is quite fat. This means many very rich people, but then also many very poor people on the left side. Yeah, and for this, then I will introduce not, I think, 1, 2, 3, 4 different measures how you can measure inequality. I will do it together with you, and then you should redo it with some data set and also some exercises for this. The next one, price indices. You know, I think everybody has already participated in my macro course. We have the GDP deflator, the overall price index. We have the consumer price index. This is the index which we use to measure inflation. And yeah, then we can also create other price indices. And there are also, yeah, mm, so to speak, different theoretical methods how to calculate these price indices. So the consumer price index is just an weighted arithmetic mean. The GDP deflator, this I have not explained in my macro course, but the GDP deflator is conceptually calculated in another way compared to the consumer price index. And I think in my macro course, let me just have a look. I think I had there one slide. And then you maybe know what or you have an idea what I mean by different price indices. This is now the German version, but anyway. Let's see. This one, this one. No. I do not have it here. Maybe in an older lecture. Maybe I skip this. Maybe somewhere here. This could be then number 5 or number 6. Oh. This I still don't know why with Chromie you cannot download the files. I don't know. Money, 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 money. No, then hopefully number 4. No, where is it? There, there it is. So here, the oops, this is the consumer. Why can I not click in this? No, 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 I don't know. So the consumer price index, and this was named um, after a guy who was called Laspierre. I don't know, within your introductory courses in statistics, I think you haven't heard about these, because in my introductory course of statistics, this was explained to us. And the BIP deflator or the GDP deflator, this is calculated in another way. This is called a Paasche index, and then the harmonized, and there then you can also read a little bit about it. You find a description at Eurostat, the European Statistics Office. There it is explained in detail, because it's also a little bit more complicated, because then they are waiting also over, I think, 2 or 3 years in history. And this is also calculated after in the way named after Mr. Laspierre. And then there is also another one who is called then Fisher index, and this is then the geometric mean of a Laspierre and a Paasche index. And what you then also can show is that all these indices are already said. The consumer price index is a classical arithmetic mean. Then you can show that the Paasche index is an harmonic mean. We have talked in the first lecture about this other way. And then, yeah, the Fisher index is the geometric mean of these two former means. And for example, the GDP deflator in the United States is, to my knowledge, calculated with the Fisher index. And then we have to admit there is, of course, no right or wrong price index. There is a reasonable or a not so reasonable one, and for all different ways how to calculate price indices, there are good reasons to do it in this way. And then it would be nice, I will introduce to you, so to speak, the general theory, and that you take then also some data and calculating some price indices, and then maybe talking a little bit about the different concepts, how measuring prices, how we should measure prices. Okay, and then I can close all these ones. Oops. Close. This one we do not need. And this we still need. And the last descriptive, there's also an R missing. And the last topic will be then descriptive forecast methods. So if you are in some company and you know your profits of the last 10 years, maybe, and then of course you want to make a forecast of the profit this year or next year or within 3 years. And yeah, I will show you here some purely descriptive methods. Of course, one main topic of this lecture is, of course, the linear regression. This, of course, you can use to make a forecast for the future. But then there are other descriptive methods where you are now not really doing very theoretical statistics, but just using and going forward with your time series. The most easy forecast or the easiest forecast is of course the last day you had. So looking outside the window, I talked already about this. This is how is the weather today, and this is then my forecast for tomorrow. Well, this is of course a very simple one, but also it is one of the most famous forecast methods because behind such a forecast we can uh, we can also argue if you have a time series where all available information you can get is already in. And maybe you have talked about this in finance lectures. And because we sometimes assume that in the price of the stock markets in the Wall Street or in Frankfurt or Eschborn, because the German stock market has moved to Eschborn, it's not in Frankfurt anymore, a small village outside of Frankfurt. Yeah, they moved because of tax competition, because the Deutsche Börse has to pay much less taxes within this small village, and therefore they moved just 10 kilometers outside of Frankfurt. And yeah, we are assuming sometimes that in the prices at the stock markets, all possible information in the world is already seen in these prices. And then, from a theoretical standpoint, we can argue that the best, okay, um, that then the best forecast is just to take the today's price. And this is the so-called efficient market hypothesis. So this then means you cannot be better than to use just this forecast. Well, and of course, then the successful broker is the guy who maybe in 5.5% of all cases is then still better than this efficient market forecast. Yeah, and there are, I think, also 3 or 4 different standard methods in doing a purely descriptive forecast. We'll go through this, and then you should also take some data and redo it, and also always 3, 4, or 5 little exercises you should then also present. Okay, so then think about this, that we later on can then take here also our groups. And yeah, we will see because some guys of you have problems to participate here on Tuesday and to present just only in front of 2 or 3 students. This wouldn't be that nice. And therefore, maybe then we can, for your presentations within this week, find another day, maybe. Also, maybe in the evening. We will see. So that hopefully then at least 5 or 6, in the best case, all other 9 students, or we have the group, all other 6, 7, or 8 students can participate. Because these presentations, you are not doing them for me, you are doing them for you, for yourself, and of course for your fellow students, so that you should learn from each other. Okay. That's it then, and then we will go on with our little case study. Where did I had it? Here, I think. No, this is macro, but statistics. And so here we had these 2 time series. The number of new electric cars. Then let's switch to English here also. Gastgewerbe in English. This is, oops. Or does anybody know what Gastgewerbe means in English? I do not know it directly. Hospitality industry, okay. Industry. Some product. So here we are. So we had our calculated with our data set already all means I had introduced. Then let's go on. What else did we have? Oops. So the range. What do we have to do when we want to calculate the range? Yep. Oh, yeah. How to calculate it? The range. Yep. Yeah, for sure. This is not, it is not very, yeah, not very difficult. So, and for this, of course, then I can go through my data. Well, looking at the electric cars here, I have the 8, and by I see in 2023, it would be these two numbers. But of course, if you have a time series of 100, then it takes some time to find it. And again, we have some possibility, some formula to create it. So it is max. And what would be then the formula for the smallest number? Very surprisingly, min. And this I find quite nice in Excel, that also the names of these formulas are quite intuitive. So, and then it is, or maybe what we should also write down here is then to see what number it is. Then let's calculate also, oops, an equal sign. So, and the nice little thing, you know it now already, is that I can just copy these formulas to the right, because it is moving then just to the right. Maybe you know this. And so here 39 is, this one is found here, and the 72 is, well, it is the first one. Okay, next one. Sample variance, biased and unbiased. What do I need for this? Well, in the end, of course, we have also a formula for this, but let's do it stepwise. What is variance? And this is something which you should just know if I wake you up in the night at 3 o'clock. Because of course we can look everything up in the internet, and also we can now directly ask the AI. And in 99 out of 100 cases, we obtain the right answer. But still, if you are starting to think about things and arguing, it's my opinion yet that you still have to have some things in your head. Because if you always have to ask the internet or the artificial intelligence, this takes too long. Or somebody is asking you something later on when you are working, when you are at your job. And then you always say, stop, I at first have to ask my mobile phone. Then maybe the guy then directly asks your mobile phone and he is not asking you anymore. And this would mean you have no job anymore. So what do I need for calculating the variance? The variance is calculated with respect to, it is a volatility measure. So a dispersion measure. How are my data points scattering around what? There's a reason why we have an introductory course in statistics. And the reason is not just to pass the exam. The reason is to know something which you later on need. It's a matter of the dispersion with respect to the arithmetic mean of your data series. The arithmetic mean of our data series we have here already calculated, and then the variance is the so-called second moment. So we need the squared distances of every data point with respect to the arithmetic mean. So let's calculate these ones. So x minus x bar squared. Up. And well, let's put this one then just inside here. This was the wrong one. And this one. So this is, oops, 61 minus the arithmetic mean of our e-cars. This is always the same point. So we have to fix it. And there I said to you, you can do this with F4 or in front of the letter and the number you have to insert a dollar sign. Um, this is moved a little bit wider, so I cannot directly copy this one because this would be, or you see it, if I now move this, then the E2 is okay, but since I have fixed the arithmetic mean, it is still fixed, and this is not the arithmetic mean of our hospitality industry. Yeah, so I have to change this then to P3. And this one I can copy now downward here. And this one we can copy downward here. Well, and overall, the formula of the biased variance was the arithmetic mean of all square distances. So I sum up all square distances and divide it by the number of my data points. So this one, sum, or I have here the sum. Then I can just copy this one. And also here, these are the sums. And then I get this divided by 21. And I get for the hospitality industry this also divided by 21. What was then the difference to the unbiased variance? Hmm? Biased divided by n and unbiased divided by n minus 1. So this I can then also just do divided by n minus 1, or I take the biased one and multiply this by 21 divided by 21 minus 1. This is not okay. Or no, it is. Yeah. So, and here also, if you are doing these calculations, please do not just do it stupidly, but then just have a look. And since I divided the same number once with n and in the other case by n minus 1, then I directly know that this number here has to be larger than the number above. Because it always happens if you are doing something like this, that you are just typing something wrong, or that you are using the the wrong cell or column or whatever. And for this, then it would be nice if you have some idea what kind of number should be there. Okay. So what else do we need? Well, the first one was the mean absolute deviation. Sorry for this. Let's move these ones down. But this is quite nice because let's introduce another two columns. And also here. Where is it? There it is. So now not the square, but the absolute distance. if I have already the square, how do I obtain then directly the absolute value? Yes, of course. So, or you have also here a formula, and this formula is called abs. And then again, you have to use the number minus the arithmetic mean. This would be also possible. And this one down here. And again, we need the sum of these absolute distances. And here we do not distinguish between biased and unbiased. So just the number divided by n. So then where are we? This would be then this number divided by n. And this number divided by n. So then standard deviation, and how did I call them? So uncorrected and corrected. Deviation and the corrected one. Well, these two are just the square roots of my variances. So again, this number should be larger than this number, of course. And yeah, so now we have a measure of dispersion, or we have now three measures or three reasonable measures of dispersion which have the same unit as the as our mean. Yeah, because the variance, there we have the square, and if then we have euros or meter or whatever, then we have meter square, euro square, and so on. And therefore, we are calculating here the standard deviation, or of course, the mean absolute distance has already the same unit compared to our mean. But still, think, for example, taking currencies, and then you can measure your capital within dollars, US dollars, or you can calculate this in, let's say, the Hungarian currency, and the Hungarian currency is forint. Let's see what kind of exchange rate we have. Forint to US dollar exchange rate. So here you have almost, let's take, this is then 103,000. So just the number of the same capital is 3,000 times higher if you are measuring the same capital in the currency of Hungary. And if we then calculate the standard deviation or the variance or the mean um, absolute distance, then of course this number will be in general much larger than if you have a capital which you are measuring in US dollars. Just because of the reason that the unit of the Hungarian currency is in general just 3,000 times larger. But still, you are just measuring capital. And then, of course, the argumentation that capital measured in forint has a larger variance. If you then just argue, well, it is more volatile, this wouldn't be very logically, because you just changed the unit. Or think of measuring the height in meters or in nanometers. Then it's, I think, a nanometer is 10 to the power of 9. And for this, then we calculate a dispersion measure where we have, so to speak, no unit. And this is then, did I have it here? Oh, I do not have it in my slides. That's a pity. Mean variance. Sample variance. Then I just forgot it. Sorry. Um, and for this, then we just calculate the coefficient of variation, where we take the standard deviation, dividing this by our mean. And then just the two units are canceling. And then we can, so to speak, comparing the dispersion if we have different units. And then the argumentation would be better if you then say, well, the coefficient of variation of one data set is larger than the other one, that you have a larger dispersion around the arithmetic mean. So let's then calculate this also. And didn't I have introduced it here? I should have. No, I didn't. So let's introduce this here. And oh, here I have it. Great. Dimensionless here. So I have done it. So then coefficient of variation. And this is then just there, of course, we again can calculate the uncorrected and the corrected. So once we take the uncorrected standard deviation divided by the arithmetic mean, and we take the corrected standard deviation divided by the arithmetic mean. And now let's see that our hospitality is roughly by a factor of 10 has roughly a factor of 10 lower dispersion around the arithmetic mean, the data series, compared to the electric car series. So, and the last one are then our third moment, the skewness and the kurtosis. For this, we need the standard deviation. This we have already calculated also for the kurtosis. And we need then the distance to the power of 3 and the distance to the power of 4. So then we need 2 more columns, and here also 2 more columns. This would be then to the power of 3 and to the power of 4. Since I have already the formula to the power of 2, I copy these two, changing the exponent. And go down here, and the same for the hospitality industry. Again, the sums and then skewness and kurtosis. Skewness, the sum of the distances to the power of 3 divided by n and divided by the standard deviation to the power of 3. And yeah, there the definitions are not always the same. I gave you here standard deviation or sigma hat, and sigma hat I defined as the corrected one. Maybe if you look it up, skewness or kurtosis within the internet, that maybe there it is divided by the uncorrected standard deviation. This could be the case. This is not always the same. Or this I said also to you, introducing the kurtosis. Sometimes this is also defined as this term minus 3. Then, and the reason for this is that using this formula here, if you calculate the kurtosis of the standard normal distribution, then the value of this would be 3. And quite often we define our measures with respect to the standard deviation, and therefore sometimes the kurtosis is defined as this formula minus 3, so that then the value of the kurtosis of the standard normal distribution would be then 0. Yeah. So if you look at this, okay, then let's do this. So equals to the sum with the exponent 3 divided, opening brackets, 21 times the corrected standard deviation to the power of 3. And here the same. So hospitality divided by 21 times now the corrected here to the power of 3. Enter. And for the kurtosis, the sum of the 4 divided by n. Up, yep. Divided corrected standard deviation to the power of 4. And the same here, divided by 21, opening bracket, times corrected standard deviation. Again, to the power of 4, closing brackets, enter. Oh, 2008. This is quite large. Can this be true? Well, here I have a kurtosis, and this I also mean, is my output reasonable? Here I directly said, well, this is reasonable because if we look at the electric cars, we had a mean of 90,000, and we start with the lowest numbers around 10, 20, 50 or something. And then in the end, in the last, especially in the last 5 years, we had numbers around 200, 400, 500,000. And then I would say this is reasonable that we then are with our data points quite close to a normal distribution. Because also you have extreme values at the borders, and around this 90,000 we have in the neighborhood, we have the most data points. So for this, I then would directly say, okay, a 3, since I know 3 would be the value which I expect if I have a normally distributed data set. This is reasonable for me. And now 2000 is quite a lot. So, and this would mean, let's have a look in the data set. Where is it here? So 700,000, and here then roughly up to 1 million. Yeah, so maybe it's also reasonable because we have a quite narrow distribution. And think of the interpretation. Many outliers with a number larger than 3. Then it should be even a little bit the other way around. Let's see if I have in the formula maybe a mistake. So that's it. This is the right one. Divided by the standard deviation. This is also okay, and divided by 21. So everything seems to be okay. And we have a standard deviation. No, we have a mean of 90,000. Well, we have here some around 90,000. But we have also 70,000 and so on, and around 100. So it could be then the case that we have maybe a distribution which has somehow 2 peaks. And this would be now my explanation for this value, that there is quite narrow, but that we have a distribution with around 2 peaks. And this would be then also the case that then relative to the mean of this distribution, since the dispersion of our data points are around very narrow around 2 other values, we have then a relatively wide range with respect to the arithmetic mean of our. This could be the case. So, and maybe then this is what if you choose this topic to present this, then yeah, you are of course free to take an own data set where you are interested in, and of course we can talk about is it if you do not find anything, but you can choose anything and then just start to describe this data set with all these measures I have shown now to you, and then go into these data you have created and just try to find out something interesting about your data set. I don't know what. Let's see. Yeah. So just an open case study. So there cannot be then something right or wrong. Just find out something interesting about your data. This is what I expect then. Okay, then we are done for the first block today. Just talk to each other, forming the groups, and the other 2 guys should come in some minutes, and then we talk about the other topics. Thank you.